All right. So here's our next section for the AWS Machine Learning Specialty walkthrough. All right. Before we get started, hit the like button, comment, and subscribe. And if you have any questions in particular, let me know. But you should definitely share this with anyone else you know who's going to be taking the AWS Machine Learning Specialty or Machine Learning Associate exam. All right. Outside of that, let's get started. So first things first, looking at the console, I want to give you a reminder again, check out your billing and budget separations. You want to basically know what you're paying for as soon as you can, because this can get costly very quickly. And if you're not doing this in your professional environment, you're going to have to pay that cost. So what we're going to do is go over an overview today of data engineering fundamentals for machine learning. All right. So machine learning success fundamentally depends on high quality data that must be ingested. It has to be ingested, stored, and processed efficiently. And S3 will serve as the cornerstone of AWS's data ecosystem. This provides infinite scalable object storage that supports the entire machine learning lifecycle. This is critical for AI applications because it offers the flexibility to store any data type while integrating seamlessly with AWS's comprehensive suite of machine learning and analytics services. But first, you have to understand the types of data and their properties. We've already reviewed this, but let's go over it again. First, you have structured data. This represents information organized in predefined schemas, typically found in relational databases with distinct columns, data types, and relationships. This data type is easily queryable using SQL because it follows consistent formatting rules. Examples include database tables from systems like Oracle, Redshift, MySQL, and PostgreSQL, as well as formatted CSV files and Excel spreadsheets with column structures. Then you have unstructured data. This lacks a predefined structure or schema, and it requires pre-processing before analysis. This will include raw text files without fixed formats, multimedia files like video, audio, or images, emails, word processing documents. So for AI applications, unstructured data often contains valuable insights, but requires sophisticated processing techniques like natural language processing or computer vision to extract meaningful features. And then finally, you have semi-structured data. Number three, this exists between structured and unstructured, and it contains some organizational elements like tags or hierarchies, but without consistent schema enforcement. Common examples include XML and JSON files, email headers, and log files. So this data type is particularly important for modern AI applications because it can accommodate varying data formats while maintaining some queryable structure. All right, so first things first, let's go into the common data sources and data formats. The first one is going to be JDBC. All right, so this is Java database connectivity. So JDBC connections provide Java-based platform-independent database connectivity, but require Java runtime environments. ODBC connections offer language-independent database access, but require platform-specific drivers. Raw log files represent common data sources requiring parsing and structure extraction. And APIs enable programmatic access to external systems with varying authentication and rate limiting requirements. And then there's data streams. These are from sources like Kafka and Kinesis within AWS and provide real-time data ingestion capabilities. So the purpose for this, all right, so standard API is for connecting to and querying databases from Java applications. This is for JDBC. So the key characteristics of this would include it's platform independent, so it'll run on any device supporting Java. It's language dependent, which means it requires Java, and it's commonly used for extracting data from external databases. So the use case for ML would be data extraction from enterprise databases for model training, and it works with most ETL tools and data ingestion pipelines. All right, so save this, go to the next one. Next, you have ODBC. All right, so ODBC is a database connectivity standard that's language independent. So the key characteristics include that it's platform dependent, so it requires specific drivers. Its language is independent, so it's not tied to Java, and it has a broader compatibility across programming languages. Within machine learning, data extraction can occur when not using Java-based tools, and it's supported by most data extraction and ETL tools. All right, so document that, save that. All right, here's another example, raw log files. All right, so you can go through here. This is just a good repo that you'll want to save to get good log files for your own usage, right? If you're doing anything, let's say gosh, if you're doing anything that you have to just test to have a lot of data, right? This will be a good way to get it. And you'll see different examples here. Android, Apache, HDFS, Linux, all right? Let's see. Let's see if we can go structured. Okay, so this is some log files. All right, so for this, you would use these for direct ingestion of systems logs, right? This will be applications logs, systems logs, and operational data. And it'll typically be stored in an S3 for cost-effective long-term retention. Then you have the use cases, right? This is good for anomaly detection, system monitoring, and behavior analysis. All right. So the typical formats are going to be plain text, JSONs like structured logs, CSV files, Excel files, or semi-structured logs. All right. Which this seems to be one, like a CSV would be somewhere in that middle. Well, actually, no, that would be a structured log file. All right. So that's a good example for you to go at. All right. And then APIs. All right. So APIs are application programming interfaces. You use these for real-time data access with external systems and services. So you can integrate this in various ways. RESTful APIs for on-demand data access, webhook integration for event-driven data ingestion, and then AWS Lambda for API polling and data transformation. With machine learning, you'd have real-time feature engineering and external data enrichment. All right, so save that. Let's go on. And then you'll have streaming data. So streaming data would be real-time data streaming platforms. And this would be with something like Apache Kafka or Amazon MSK, right? So these would be distributed event streaming platforms. So some real use cases would be real-time model inference, continuous feature updates, and online learning pipelines. All right. So this would be that almost agentic. All right. And then we can go into common data formats. All right. So the first one, CSVs. We've shown you one. We talked about it. All right. So what is a CSV? That's comma separated values, right? So this provides human readable, text-based tabular data storage, ideal for small to medium data sets. So CSV serves as a common interchange format between systems and supports easy editing and processing. It's really useful for structured data that needs to be human readable and easily imported into various tools. So the basic structure is going to be tabular. It's going to be row-based, right? Some characteristics include that it'll be human readable in the text format. It'll have a simple delimiter-based structure with the commas. And the delimiter can be actually, it can be a comma, it can be a pipe, it can be a tab, it can be other characters as well. All right. So best practices would be use this for small to medium data sets, handle the commas within data usage, proper escaping and quoting, using proper escaping and quoting. And then consider UTF-8 encoding for international characters. So basic use cases, right? You'd have structured data import or export. You could have database interchange formats, and it's compatible with Pandas, Excel, and most machine learning tools. And also with SageMaker, you can have it also supports the CSVs, right? What does that mean? It means factorization machines. It means the k-means. These are the algorithms. Factorization machines, k-means, k-nearest neighbor, linear learner, PCA, random cut force, and XGBoost. And I gave you a lot there, but we're going to cover these later. All right. So here's some performance considerations. One, it's not efficient for large data sets. Two, there's no built-in compression. And three, sequential read is required. All right. Next, we'll go into JSON. So this is very popular. All right. So what is JSON? JSON is JavaScript object notation, right? This is a lightweight human readable interchange for data that's structured and semi-structured using key value pairs, right? And let's see if we can see on this, but you can see how this is set up. All right. It's a nice dictionary for it. All right. So the structure would be key and value. So you can see this white space, you see the colon, you see value. All right. Unfortunately, this is an image and not, and not, and it's not an actual text. All right, but that's okay. All right. So it supports nested structures, which you can see on the right side of the screen. And here's some characteristics. One, it's human readable. It supports semi-structured data. It has a flexible schema, meaning different objects can have different fields. So the best uses would be JSON lines can format for streaming data. It can validate a schema for consistency, and you can consider compression for storage efficiency. Within machine learning, you'd use this for semi-structured data storage, for configuration files, for web API data exchanges, and for NoSQL database storage. Think like MongoDB or DynamoDB. All right. And within SageMaker, you use deep R forecasting, right? That would be JSON lines format. And then within AWS, this will work really, really well for Amazon Comprehend for text analysis, that key value pair. So you could set definition, something in English to be translated into French or whatever. Or you could use it for Amazon recognition for metadata storage, right? So you could look at an image and have that metadata. It would be something similar to what you would see for, what do you call it, an accessibility features for a photo for someone who is vision impaired or visually impaired. All right. Next, we have Apache Avro. All right. So this is one of the main pages you're going to see for it. You can look into this deeper, but go to the project. All right. Let's see, papers, Apache Avro. All right. So this would be a good paper to have for it. Ugh, I do not want to get that. All right. But save that. Let's manage, reject. All right. But read this. Okay, so what is Avro, right? Avro provides binary format storage combining data and schema for efficient processing across different systems. So this format excels in big data and real-time processing scenarios where schema evolution is important. And Avro's binary nature enables efficient serialization for data transport, while embedding schema information ensures compatibility across different processing systems. But basically, the structure would be binary, row-based format with embedded schema. Let's see if we can get in here and show you. All right. Let's go in here. Sure. Make tools. Okay. So what are the key features, right? So there's a schema evolution support. It's self-describing. So it's a schema with data and metadata, right? So what's the benefits of this, right? It's efficient serialization, meaning you can do this in order, right? And it's good for data transport. The schema is compatible across different versions, and it's language neutral for data exchanges. So within machine learning, this could be used for big data processing pipelines, real-time streaming with schema changes, and then data exchange between different systems. All right, and it'll work in AWS, especially with Apache Kafka, Amazon MSK, Apache Spark on EMR, Apache Flink, and the Hadoop ecosystem, right? So you'll use this when the schema will change over time, or if you need efficient data transportation or transport, or you're working with streaming architectures. Okay, so we'll save those. Let's close that and that. All right, and then you have Apache Parquet. All right, so Parquet is a columnar storage format optimized for analytics where queries typically access specific columns rather than entire rows. So this format enables efficient compression and encoding because columns contain similar data types. So Parquet proves invaluable for large data sets and analytics engines, and it supports distributed processing and minimizing input-output overhead for column-specific queries, right? So this will be used specifically for column storage format, all right? And here's a documentation on it that you should save for yourself. All right. But what does this mean? What is benefits for it, right? So the column-based storage means it only reads needed columns. And there's efficient compression, right? So that better compression ratio is better than, let's say, a row-based format because you're just only looking at the certain columns instead of all the rows. Then it has a push down. So it can filter data at the storage level. And then you can maintain data types and metadata types while stored. All right, so performance-wise, it has faster analytical queries, meaning it can read specific columns only. It can reduce those input-outputs for analytics workloads, and that efficient storage is great for utilizing it in your machine learning workloads. So this is really good for like a large-scale analytics, data lakes and warehouses, feature stores, or training data sets with many features. All right, and this will be used within certain AWS services, including Amazon Athena with native support, Amazon Glue with ETL transformations, Amazon Redshift Spectrum, and Apache Spark on EMR. All right, so the best practice is to use this for heavy read analytic workloads. If you want to partition data for better performance, or if you want to choose compression, something like just Snappy or gzip. All right, make sure you store that. Okay, and we'll store this. Okay, all right. But here we go. When you're doing machine learning, you need to consider your access patterns. Why? This is your data formats, okay? Your access pattern is going to determine a lot. First would be your analytical queries, right? For something like this, you want to use Parquet for column-based analysis. Why? That read-based and that compression efficiency. Then you're going to have row-based operations. That would be another one to consider. For that, you use something like JSON for full record processing. Or if you have something like a simple tabular data, then you go to the CSV for like a basic structured data format. And finally, you have a semi-structured. With that, you'd have JSON for a flexible schema. All right, so remember that there's multiple uses, and then algorithms have certain compatibilities with these file types and these file format types. So let's go to this. CSV, structured. JSON is good for time series or for semi-structured. You have Parquet for efficiency for large analytical data sets. And then you have text files. That'll be those unstructured or semi-structured for natural language processing and text and was it computer vision, right? And then you have to remember cost considerations. The cheapest is going to be Parquet because it has that efficiency, then JSON, then CSV. For query performance, you're going to have Parquet, remember that read efficiency, and then JSON, and then CSV. For schema flexibility, it'll be JSON, right? Because you can have those key value pairs line up for what you need. Then Parquet, because it operates in a similar fashion, but with that read efficiency, it helps. And then CSV. And then compression efficiency. Parquet will lead that, then JSON, and finally CSV. So this will be the first portion of it. And we'll go next into a little bit more on S3. Outside of that, I hope you enjoyed this lesson and you come back for the next one. If you have any questions, drop a comment. Until then, remember to like, share with anyone who's taken the AWS Machine Learning Associate, and subscribe. Have a good day.